In the previous couple lessons, we talked about, in general, what a discrete probability distribution is. And we looked at the charts and we listed out all the possible x values with their corresponding probabilities. And we saw that all of those probabilities added up should be 1. And we just looked at the different characteristics of a discrete probability distribution. Now, in this section, we're going to specifically talk about a binomial distribution. That is one specific kind of probability distribution that is discrete. Now, in order to talk about the binomial distribution, you have to understand where it comes from. We have to do these experiments over and over again, and when we list all the possible outcomes of these binomial experiments, that's what makes up our binomial distribution. So we need to understand what a binomial experiment is. And in order to have a binomial experiment, we need 3 characteristics. So the first characteristic is that there are a fixed number of trials. Okay, 2, the second characteristic is there are only 2 possible outcomes, what's called success or failure. Now, success and failure doesn't necessarily mean that it has a bad or positive connotation with the results. What you need to understand is whatever the results are that you're looking for, that would be considered your success, and the results that you're not looking for would be failure. So success and failure doesn't necessarily have to have a positive or a negative connotation with it. So just be aware of that. Okay, and the third characteristic is that the trials, each of these trials or these experiments, each trial is independent and repeated under the same conditions. Okay, now up here is our notation for the binomial distribution. The B stands for binomial, and then you have the little tilde, which is the little squiggly line, and then in parentheses you would have your value of n, which is your number of trials, and your value of p, which is your probability of success for each individual trial. If I was to perform a binomial experiment to create a binomial distribution, let's say whatever my experiment is, I was doing it 20 times, and whatever my outcome was that I was looking for, the success was, say, 0.25. So this is how I would describe my distribution using our fancy notation. As you scroll down here, you'll see some more notation. N represents the number of trials, and that's the same N up here. It's the number of trials. That's your N here. P is your probability of success in a single trial, which that is what I put here. That's your probability of success. Q is the probability of failure, so it's going to be the complement of P. So if my probability of success is 0.25, then the probability of failure is going to be 0.75 because I subtract from 1. So that Q represents my probability of failure. X is the variable that tells me how many successes I have. So X can be anywhere between 0 and n. So for example, if I stick with the example where I have 20 trials, I can't have more than 20 successes because I'm only running 20 trials. So my number of successes could be 0, it could be 1, it could be 2, I could have 3 successes or 4 successes, all the way up to 20. So your X is only going to be values from 0 to n. Now, if you want to find the mean of your binomial distribution, you take your value of n times p. If you want to find your standard deviation of the binomial distribution, you take the square root of n times p times q. In this example, we're just going to work through and find the key elements of what we need when we're looking for a binomial distribution. So it says, at ABC College, the withdrawal rate from an elementary physics course is 30% for any given term. So we need to define what success and failure is. Okay, if I randomly started picking students, every time I pick a student, if they said they withdrew from this physics class, I would count that as a success. Again, that doesn't necessarily mean that it's a positive thing. It's just what we're looking for. So success is going to be defined as they withdraw from the class. So failure means that they don't withdraw from the class. Which means the probability of success is going to be 0.3. Remember, we're calling success is if we ask a student and they say they withdrew from the class, and that is 0.3, which means failure is going to be 0.70. Now, X is the number of successes. Which in this case, it's the number of students that withdraw from class if you went around and picked a sample. So let's say I picked 10 students. So I would be doing 10 trials. Each time I pick a student and ask them, did you withdraw from class? That's a trial. So if I pick 10 students and I asked each student if they withdrew, and let's say 4 of them said that they withdrew, then my X would be 4. It's my number of successes. Okay, so in this case, if I let N be 10, X could be 0, 1, 2, all the way up to 10. I could have 0 successes. I could have 1, 2, all the way up to 10. And if 4 of them said they withdrew, then my X would be 4. Now, when we're computing probabilities based on the binomial distribution, there is a formula for that. However, in this class, I like to use the calculator as much as possible to save you guys the arithmetic. And so the calculator functions that we're going to use for the binomial distribution is these two here. We have the binomial PDF and the binomial CDF. And what you enter in on the calculator is you put in your number of trials, that's this here, your probability of success, and then your number of successes. Now, the difference between the PDF and the CDF is for the PDF, this is for a specific X. So we're going to be looking at just one value of X, like X is 4. We have 4 successes. Or X is 7. We have 7 successes. We're just looking at a specific number of successes, just one X, okay? Binomial CDF is when we are looking at more than one X. And I'm going to call that the accumulated probability. So when we're trying to find the probability of more than one value of X, we're going to call that accumulated. Suppose you play a game that you can only either win or lose. The probability that you win any game is 55%, and the probability that you lose is 45%. Each game you play is independent, and you play the game 8 times. When I look at this, I think about a binomial distribution because you can either win or lose, success or failure. There's only 2 possible outcomes. The problem says that the trials are independent, and we have a fixed number of trials, which is 8. So we're going to say N is 8. That's the number of trials, which means for our X values, that's the variable. That's your number of successes. So in this case, since we're doing 8 trials, we could have 0 success, 1 success, 2 success, all the way up to 8. Which means, remember, the number of wins. Let me put that over here. So we're going to call success if you win, and we're going to call failure if you lose. So if you look at this chart, in the first column, I have listed all the possible values of x, so 0 through 8. The second column, where it lists all the probabilities, this is the PDF because it's the probability of that specific value of x. So for example, when you look at that first probability, 0.0017, that is specifically the probability that you have 0 wins. If I look down, for example, where x is 3, and you see that probability is 0.1719, that 0.1719 is the probability that you win the game 3 times. Now, that is your PDF column. And when I calculated these values, I rounded to 4 places. So just keep that in mind. That might be off a little bit because of rounding, but it should come out pretty close when we add it up and get 1. Now, for the accumulated probability, that means, for example, if I look at x equals 3 in the accumulated column, which is the CDF, that means I took all of the PDFs from 0 to 3. So I added all of those PDFs. So 0.0017 plus 0.0164 plus 0.0703, and then finally 0.1719. I added all of those up and got 0.2604. Another example, let's look at x is equal to 5 in the accumulated, the CDF column. When I look at that 0.7799, that is all of the PDFs, all of the probabilities for 0 through 5, including 5, added up. And because this is a probability distribution, by the time we get to the bottom, on the last one, when I add them all up, I should have a total of 1. So this is the difference between the PDF and the CDF. So the PDF is a specific value of x. It's the probability for a specific value. And then your CDF tells you the sum of all the probabilities from 0 up to that value of x that you're looking for. So for example, we just talked about x is equal to 5. So if I look at the CDF column, x is equal to 5 in the CDF column means all of the probabilities for the individual values of x's are added up. 0 plus 1 plus 2 plus 3 plus 4 plus 5. All of those are added up. Okay, so let's look at the first example, and then I'm going to go through and show you how to find these functions on your calculator. We have to find the probability that you win at most 5 games. So what that tells me is at most 5 games means 5 is going to be the biggest. So we want to find the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. Now, we can find those individual values from the PDF column and add them up, or we could do it all in one shot because I know the accumulated CDF column counts everything from 0 up to that value. So since I'm looking for the probability that x is less than or equal to 5, really what I'm doing is I'm looking at the binomial CDF of 5 because I'm counting everything up to 5. So we're going to punch in on the calculator, binomial CDF. I'm going to put in my number of trials, which is 8. I'm going to put in my probability of winning, which is 0.55. And then I'm going to put in that value of x that I want to tell the calculator to add all those probabilities up to and including 5. When we put that in on the calculator, we should get 0.7799 when it's rounded to 4 places. So we could either add all of the individual values up, so we would find the PDF of each of those separately and add them up, or we could just do the CDF of 5, which would add all of them up to that point for me. Okay, so now let's hop over and let me show you how you can access the binomial PDF and CDF on the calculator. So to access your binomial PDF and binomial CDF functions, what you're going to do is you're going to look by your arrow keypad or by your clear button. Right next to that, it should say VARS, V-A-R-S, this button here. And then above the VARS button, there'll be a shift menu, D-I-S-T-R for distribution. You want to hit the second button and then the VARS button in order to access that distribution menu. So you're going to hit second VARS, and then you'll have a whole bunch of distributions that come up. You want to scroll down until you find binomial PDF and binomial CDF. And the example that we're currently doing, we're doing a binomial CDF. So I'm going to choose this option here. On mine, it's option B. Yours might be a little bit different. Okay, so I'm going to hit enter, and then I'm going to put in 8 for my trials. I'm going to enter in 0.55 for my value of P, my probability of success. And then we want the calculator to add up all the probabilities from 0 up to and including 5. So I put 5 here, and then I hit paste and enter. Now, if your binomial CDF function looks different than this, and rather than coming to this screen here, it brings you directly to the home screen, you're just going to have, in the parentheses, you'll put 8, and then you'll hit your comma button, which is above the 7, and then you put in your value of P, then your comma button, and then you put in your value of 5, and then you close parentheses. Your parentheses are here above the 8 and 9 button. You want to close your parentheses and then hit enter. Most of you will probably have this, but some of you might have a different model where it comes up directly to the home screen. Now, for those of you who have this model, once you enter everything in, you hit paste. You hit the enter button to hit paste, and then it will come up like this, and then you hit enter, and it will give you your probability. Now, we rounded to 4 places, which is what most statisticians like to do, is round to 4 places when it comes to probability. So because this value here, 6, is 5 or bigger, this 8 would bump up to a 9, and that's where I got the 0.7799 from. For part B, it says find the probability that you win exactly 5 games. So that means I'm trying to find the probability of just having 5 successes. So let me clear this out. The PDF is what gives me the probability for the specific value of successes, which is this. I don't want to look at the accumulated, the CDF, because that gives me all of the probabilities from 0 up to 5 added up. We just want specifically just for 5 games. So in this case, I'm going to do binomial PDF, because the PDF is just for the single value, and I'm going to put in 8.55, and I'm going to put in 5. So notice these are very, very similar from part A to part B. This is saying that I specifically want it for 5 successes only. This CDF is telling me I want all of them from 0 to 5 and added up. Okay, when you put this in on the calculator, you will get 0.2568 when it's rounded to 4 places. Let me go ahead and show you how to do that on the calculator now. So we're going to go to the same menu to access binomial PDF this time. So I'm going to hit the second button and then the VARS button to access the distribution menu. And then I'm going to scroll down and look for binomial PDF. On mine, it's option A. So I'm going to choose enter. And then I'm going to put in all the same information. We've got 8 trials. My probability of success is 0.55. and my X value that I'm looking at is 5 successes. So then I'm going to go ahead and paste it and hit enter. So what we're putting in on the calculator is exactly the same as far as the N, the P, and the X. But because they're different function, one is for the specific value of X, one is for the accumulated probabilities, we're going to get different answers. So when I round this to 4 places, I get 0.2568. Now let's look at part C. It says find the probability that you win more than 5 games. So that's telling me I want to find the probability of winning 6 games plus the probability of 7 games plus the probability of 8 games. We're not going to have an X over 8 because it says we play the game 8 times. So we're looking for these probabilities. Now, what we could do is we could find the individual values for 6, 7, and 8, those probabilities, which are here, here, and here, and we could add them up separately. So I would have to use, unless you have a table like this, you would have to use binomial PDF 3 times on your calculator, get those values and add them up. Or what you could do, another way to do it, is since I know that all of these together, the accumulated CDF, when I get down to the bottom, everything is added up to 1. So what I could do is since I want 6, 7, 8, those values added up, I could find 0 through 5, which we have that added up, and subtract it from 1. And what's left over is going to be the sum of 6, 7, and 8, because in total it has to be equal to 1. So you could either do the binomial PDF 3 times and add those values together, or you could find from 0 to 5 what that value is, which is 0.7799. That's the CDF, and subtract it from 1. So I'm going to try it the other way where you just have to do a subtraction problem from 1. So to find the probability that I have x's greater than 5, I'm going to use 1 minus, and I'm going to find all the values from 0 to 5, which is binomial CDF from 0 to 5. I'm going to put in 8.55 and 5. So this here is going to give me the sum of everything from 0 to 5. When I subtract it from 1, what's left is the sum of 6, 7, and 8. So when I do that, I'm going to get 0.2201. So in this example, since we're going to subtract from 1, before I go to the menu to get my binomial function, I'm going to hit the 1 minus button. So then when I go do my binomial function, it will pop up where this cursor is here, and I can do it all in one step. So make sure you have on here 1 minus, the cursor is blinking after the minus, and then when I go to the second bars button and I do binomial CDF, I'm going to put in that we're doing 8 trials. My value of P is 0.55, and we're going to add everything up to 5, all of those probabilities, and then I'm going to hit paste. So now when I paste, I can do it all in one step because it came up after the minus. So this value here will calculate it automatically and then subtract it from 1. When I hit enter, it gives me the value of 0.2201. All right, we're going to look at part D now. This one says win at least 5 games. So this is, I want to see what I get if I win. What's the probability of 5 games? plus 6 games, plus 7 games, plus 8 games. It's basically part C, but we're adding in 5. At least 5 games means it can include a success of winning 5 games. So this is going to be x is greater than or equal to 5. So what we're trying to find is the probability of winning 5 games plus the probability of winning 6 games plus the probability of winning 7 games plus the probability of winning 8 games. So if I look at the chart, I could do it individually by finding each of those PDFs, which would be all of these, and add them up. Or, since I know the total has to add to 1, I could take 1 and subtract the CDF, which would be this, up to 4. Because I don't want 0 through 4, I want 5 through 8. So I would find the CDF up to 4 and subtract that from 1. And what would be left over is the 5 through 8. So, in the calculator, if I use that trick where I subtract from 1, in this case, I would do binomial CDF, subtract it from 1, but when I put in my value for x, what I want to subtract off, since I want to include 5 in my answer, I want to subtract off everything up to 4. So that's what I'm going to put here. And when you do that, you're going to get 0.477. So keep in mind that I have this chart already filled out for you, so you can see where the PDF and CDF values are coming from. But most of the time, you're not going to have that chart in front of you. So if you have a lot of values that you want to try to add up individually, it's going to take some time. Whereas if you just use the trick where you subtract from 1 and you only have to do one calculation with the binomial CDF, it makes it a little bit easier and a little bit quicker. Okay, now we're going to work through the last part in this example. Okay, in part E, it says find the probability that you win. Oops, that's a typo. Ignore that D. Find the probability that you win between 5 and 7 games inclusive. That inclusive means that you're including the 5 and the 7. So we're finding the probability of 5 plus the probability that you win 6 games plus the probability that you win 7 games. So if you look up here, since we have the individual probabilities listed out here in my PDF column, I could just simply add these since these are the ones that we want. So I could do PDF 3 times for 5, 6, and 7 and add up those values. However, if you have a lot of values that you don't want to worry about doing that, you could use the subtraction trick again. What you could do is you could find the CDF from 0 to 4. So that would be this value. And then you could find the CDF from 0 to 7, which would be this value. And when you subtract, what you're going to have left over is the sum of these. So we're going to take the binomial CDF of everything up to 7, because we want to go up to 7 here. So I want the calculator to tell me all the probabilities added up to 7. So we're going to put in our number of trials, our probability of success, and our value of x that we want to count up to and add everything up to. Then I want to subtract off the stuff I don't want. So I don't want, let me highlight it in a different color here. I'll use yellow. I don't want all of this from 0 to 4. I want 5, 6, and 7. I don't want anything below 5. So I'm going to subtract the CDF that goes up to 4. So I'm going to subtract binomial CDF of everything from 0 to 4. And when I get rid of everything from 0 to 4, what I'm going to be left with is 5, 6, and 7. So I'm going to put in 8.55 and 4. This binomial CDF up to 7 will give me this 0.9916. The binomial up to 4 will give me this 0.523. And when I subtract them, what's going to be left is just the 5, 6, and 7 added up. So that's going to be 0.4686. So let me show you how you can do this on the calculator, this example. We want to make sure we're starting on a blank line. Sometimes people forget to check that, and they might have an 8 there, and then when they enter in the binomial here, the calculator will think it's 8 times the binomial. So you want to make sure that you don't make that mistake, so always make sure you're starting with a new line. Okay, so we're going to take one binomial and subtract another. So I'm going to hit the second in the vars button to access the distribution menu. And then I'm going to scroll down and find binomial CDF. I'm going to put in my trials, my probability of success, and what values of X do I want the calculator to add up. All those probabilities from 0 to 7. So I put 7 here, and I'm going to paste it to my home screen. Now, I want to take that binomial and subtract another binomial. So I'm going to subtract, and then don't hit enter. Just leave that blinking there, and then we can insert the next binomial. So I'm going to hit second vars, and then I'm going to add in the second binomial. This one's going to go up to 4, so that we subtract 0 through 4. Then I'm going to hit enter on paste, and now I have, if I arrow over, I can see the whole thing, but it's one binomial, and then I subtract the next binomial. And this lets me do it all in one step to make it easier. And then when I hit enter, then it gives me my final answer. Because this is an 8, I'm going to round that up to a 6. So my final answer should be 0.4686. In this next example, it says, it has been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. If 20 adult workers are randomly selected, find the probability that at most 12 of them have a high school diploma. So we're looking for the probability that at most 12 of them have a high school diploma. We're going to call success as having a diploma. And we'll call failure no diploma. Now I'm setting it up like this because what we're looking for is the probability that at most 12 of them have a high school diploma. So that's why I'm aiming at having success as having a diploma. Now, it tells us that they're going to randomly select 20 adult workers. So that means we're going to have 20 trials. Every time we pick a person, that's a trial, and we find out if they have a diploma or not, and that's considered our experiment. So our X's can take on anywhere from 0, 1, 2, all the way up to 20. Now, our probability of success, that's our P, that's going to be 0.41. And our probability of failure, even though it doesn't say it in the problem, I know that it's going to be the complement of P, so that's going to be 0.59. Now, we need to find the probability that X is less than or equal to 12, because in the problem it says at most 12. So 12 is going to be the highest number. So we want to find the accumulated probabilities from 0 to 12. So we can find the probability that X is 0 plus the probability that X is 1 plus the probability that X is 2, all the way up to the probability that X is 12. find the individual PDF values and add them together, or since this is going from 0 to 12 and we're looking for that accumulated value of all those probabilities, we can just do binomial CDF from 0 to 12. So I'm going to put in my n, which is 20, my probability of success, which is 0.41, and I want the calculator to add all the probabilities from 0 up to 12, including 12. So this is what I'm going to put in on the calculator, and I'm going to get 0.9738. So take a minute, now that you've seen how to put this in the calculator, and we've practiced in all the parts of the previous example, take a minute and make sure that you can get that value on your calculator. All right, up to this point, we've really been focusing in this lesson on the difference between the CDF and the PDF and how to access those functions on the calculator and how to define success and failure and all those things. We haven't yet practiced how to find the mean and the standard deviation of a binomial distribution. So just a quick example. We're going to use this example to calculate it. If we scroll back up to the beginning, on the first page of the notes, I have up here, to find the mean, you take your n times your p, and to find your standard deviation, it's the square root of n times p times q. So that's what we're going to do. So come back down here. We're going to go through how to do that. So to find the mean of this binomial distribution, I'm going to take n times p, in this case, n is 20, and my probability of success is 0.41, and I'm going to get 8.2. So what that tells me is, on average, when I pick these 20 adults, on average, I'm going to find 8.2, or you can round it to the nearest person because you don't want to have 0.2 of a person, but 8.2 is the average number of workers that you're going to find that have a diploma. Now for the standard deviation, we take the square root of n times p times q. So we're going to take the square root of 20 times 0.41 times q, which is 0.59. When we do that, we're going to get approximately 2.2. And so there's our standard deviation for this binomial distribution. Let's look at the last example. Again, in this last example, we don't have a table. You can certainly make one if you'd like, but most of the time, there's going to be numbers high enough that you probably don't want to go through that. For example, in this one, it says we're dealing with 50 students. So to try to make a table with 50 values for PDF and 50 values for CDF, it'd kind of be a little rough. Okay, so in this example, it says approximately 70% of statistics students do their homework in time for it to be collected and graded. Each student does homework independently. In a statistic class of 50 students, we're going to find all of these probabilities A, B, and C. And it also adds in here that the students are selected randomly. So let's call success. Since if you notice, all the questions are asking about students doing their homework on time. So we're going to call success of students doing homework on time, and failure will be students that don't do their homework on time. Okay, so that means the probability of success, which is our P, is given in the problem is 0.70, and our probability of failure, which is our Q, the complement, will be 0.30. Now in part A, it says, what is the probability that at least 40 will do their homework on time? So what that means, at least 40 means 40 is going to be the lowest. So we want numbers greater than or equal to 40. We want the probability of having 40 students do them on time, 41, 42, 43, all the way up to 50. Now, because this doesn't start at 0, it's not 0 to some number, we're going to have to use the subtraction trick. I want to do binomial CDF, and I want to subtract off everything I don't want. I want 40 and up, so I'm going to subtract off 0 to 39. So I'm going to put in my number of trials, which is 50, my probability of success, and then I want to subtract from 0 up to the number I don't want, which is 39. I want to keep 40 and up. So when I put that in on the calculator, you should get 0.0789. So take a minute and make sure you get that. Now the next question says, what is the probability that at most 40 will do their homework on time? At most 40 means 40 is going to be the biggest. So we want everything less than or equal to 40. So we want 0, 1, 2, 3, 4, all the way up to 40. That is the CDF directly without having to subtract. We want 0 to 40. We want to count everything up to 40. So I'm just going to do binomial CDF, and I'm going to put in 50.70, and I want the calculator to add up all the probabilities from 0 to 40, including 40. When we put that on the calculator, we should get 0.9598. In the last part, it says, what is the probability that exactly 40 will do their homework on time? So now we're looking at not a bunch of numbers, just one specific value. We want 40 successes. So that means we're looking at this. The probability that X is equivalent to 40, which means we're looking at the PDF function, not the CDF. We want just that specific value. So we're going to do binomial PDF, and I'm going to put in 50.70 and 40. And when I put that in on the calculator, I'm going to get 0.0386. So you should check it and make sure you get the same value. So in conclusion, you want to remember that the CDF function on your calculator calculates all the probabilities from 0 all the way up to whatever number you put in for your value of X. Your PDF only gives you the probability for that specific value of X. And if you're not counting up the probabilities 0 up to some number, you can use the subtraction trick to figure out what it is that you do need.